Today we're going to talk about transformations. By the end of this lesson, you should be able to recognize and graph a function given its equation. The method we're using is called the transformational approach. And you should be able to describe the domain, range, and end behavior for each function, which we've already learned. So think back to Algebra 1 for a minute. You talked about point-slope form for a line. The equation for point-slope form was y minus y1 equals m times x minus x1. For point-slope form, the point x1, y1 was our starting point, and m is the slope. For transformations, we're not going to use m, x1, and y1. We're going to use a, h, and k. So if we rewrite the point-slope formula using a, h, and k, it would be this linear function here. You can see that we have a instead of m, x or h instead of x1, and k instead of y1. Last class we also talked about 5 different types of functions. We talked about quadratics, cubics, absolute values, square roots, and cube roots. You can see all of these equations here. They look very similar. All of them have y minus k on one side of the equal sign, and on the other side of the equal sign have a followed by either parentheses, absolute value bars, or radicals containing x minus h. A, h, and k each do something to transform the original parent function. A will stretch the function, or stretch the graph. And if a is negative, it will flip the graph upside down. H moves the graph horizontally, and K moves the graph vertically. So let's take a look at a few problems. When we're going to graph these equations, the best thing to do is to follow these 3 steps. First, identify the parent function pattern that you learned last class. Then, state h and k to find your new starting point. Plot that point and use a to help you graph the rest of the function. So let's take a look at example 1. This is a cubic. And if we look here and list out the values of a, h, and k for this function, remember that a is the number in front of the parentheses. So since there's not a number written here, a is 1. H is inside the parentheses, and the tricky part here is that all of the equations on the previous slide have x minus h in the equation. So because the minus is already in the equation, h is just going to be 3. And then k is the number being added at the end, which is 1. So on this graph, since a is 1, it is not going to stretch the graph. It will have no effect. Since h is 3, h moves the graph horizontally. This is going to shift the graph 3 units to the right. If h was negative, it would shift the graph to the left. And since k is positive 1, k shifts the graph vertically. Our graph is going to move 1 unit up. So We've identified a, h, and k. Let's look at the parent function pattern. So for a cubic, you should remember the xy chart we used is -2, -1, 0, 1, and 2 for the x's, -8, -1, 0, 1, and 8 for the y's. We said that the point hk is our starting point. So the point 3, 1 is going to be our starting point. Now, I'm going to use this XY chart to help plot the rest of the graph. I'm going to think of this point, HK, as the new 0, 0. So this XY chart tells me how to move from this point HK. So I'm going to move -2 in the x direction, which means 2 to the left, and -8 in the y direction, which means down 8. So from this point that I've already plotted, I'm going to move left 2 and down 8. Now I'm going to move to the next point. I'm going to move left 1 and down 1. And I always start again from that new point HK. Then I'm going to move right 1 and up 1. And then right 2 and up 8. And then I connect the dots. You can see that this is the same shape as the regular cubic function, but instead of it going through the point 0, 0, it is moved over to the right and up a little. Now, if you're a more visual learner, you can start by graphing the original function, just a regular old cubic. And I'm going to connect this with a dotted line. And you can see that all I did was shift this graph 3 to the right and up 1. So I started from this point, moved it over 3 and up 1. This point was moved over 3 and up 1, etc. I don't care which method you use to graph it, as long as you get the correct graph at the end. So if you need to draw the original graph and then move it over 3 and up 1, that's fine. Or if you can do it just using the chart, or if you can do it in your head, that's great. Let's take a look at the second function. This is a cube root. And if we look at the values of a, h, and k for this, remember that a is the number in front of the cube root symbol, which in this case is again 1. So that will not have an effect on the graph. We'll see some problems in a minute where a is something other than 1, and that will change the graph. H is inside the cube root with the x, so in this case h is 1, and that will move our graph 1 unit to the right. And k in this problem is on the left side of the equation with y. The problem can be written this way, that's fine, or we could subtract 2 from both sides and put a -2 at the end. Either way, k is going to be -2, which means that the graph will move down 2 units. So if we take a look at the xy chart for cube root functions, Now, our starting point is going to be the point HK. So that's 1, -2. Remember, this is like my new 0, 0 point. So I'm going to use the same method that I used on the first problem. I'm going to start by moving 8 to the left and down 2. Then 1 to the left and down 1. 1 to the right and up 1. And 8 to the right and up 2. Remember, you always start counting from the point HK. So if I connect these points, I have a nice cube root function. Now, for this unit, you are not allowed to use calculators, but in the future, you could check your graph by typing it into y equals on the graphing calculator. And even now, you can use that to check your answers, but you will not be allowed to have a calculator on the quiz or the test. Number 3 is a little bit different. First of all, it's a square root function. If we take a look at A, H, and K, A is the number in front of the square root, which is 2. H is the number inside the square root with x. Since there's no number being added or subtracted to x, h is going to be 0, which means we will not move the graph horizontally. So this has no effect. And k is the number that would be added out here at the end of the function or on the left side of the function with y, which again will be 0 because there are no numbers there. So since a is 2, this is going to stretch the graph. So we're not moving it, we are just stretching it. So if I write out the xy chart for square root function, now my starting point is going to be at hk, which is 0, 0. But since I have an a value of 2, I cannot just graph my regular square root function. I have to stretch it. A affects the y values, so it's going to make all of the y values twice as tall. If you really like the xy charts, my suggestion is to make a third column that's a times y. So I'm going to multiply all of these y values by a, which is 2. And then instead of going over 1 and up 1 or over 4 and up 2, I'm going to cross out the y column and use x and ay to graph my points. So from my starting point of 0, 0, I'm going to go right 1 and up 2. Then I'm going to go right 4 and up 4, right 9 and up 6. And draw my square root function. I'm going to sketch in the original square root function so you can see what happened. Having an a value of 2 makes the graph twice as tall. So you can see that instead of going up 1 unit, we went up 2. Instead of going up 2, we went up 4. Instead of going up 3, we went up 6. If you need to do that visually or with the table, that's fine. If you can do it in your head, that would be even better. But whatever way makes it easy for you to understand is fine. Now let's take a look at number 4. This one's going to be a little bit more complicated. This is an absolute value function. And if we take a look at the a, h, and k values, remember a will be the number in front of the absolute value symbols, which is 2. H is inside the absolute value bars. Now again, I mentioned earlier that h is a little bit tricky because the formula says that x minus h is inside the absolute value bars. So since I have x plus 1, that's technically x minus -1, so h is -1. If you want to, you can just think that you always have to change the sign of h based on whatever's in the equation. You have x plus 1, so you're going to change it to -1. And then we have y minus 3. You can either just change the sign of that and say that k is 3, or you can add 3 to both sides so that k is at the end of the function. Since a is 2, this is going to stretch the graph. Since h is -1, it's going to move the graph 1 unit to the left, and k is going to move the graph up 3 units. So let's write out my XY chart. -2, -1, 0, 1, and 2 for my x values, and 2, 1, 0, 1, 2 for my y values. Now I'm going to plot the point HK, which is -1, 3, as my starting point. And since I have an a value of 2, I'm going to go ahead and make a third column to my chart that is a times y. So I'm going to multiply all of these y values by a, which is 2. And then I'm going to cross out the y's because I don't need them anymore. So from my starting point of HK, I'm going to move 2 to the left and up 4, 1 to the left and up 2, 1 to the right and up 2, and 2 to the right and up 4. And then I can connect the dots. So this graph has been moved to the left and up and stretched. Let's take a look at the last problem. This is a quadratic. Let's write out a, h, and k. Remember, a is in front of the parentheses or the radical or the absolute value bars. So a is going to be -1/2. Since a is negative, it's going to flip the graph upside down, and the 1/2 is going to stretch it. H is inside the parentheses, so h is 2, and that will move the graph to the right. And k is at the end of the function. So k is 5, that will move the graph up. Now, let's draw the XY chart. We can do -3, -2, -1, 0, 1, 2, and 3. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0, 1, 4, and 9. I'm going to go ahead and plot my point HK, which is my starting point. That's the point 2, 5. Then I need to add a column to my XY chart that is a times y. So I'm going to multiply all these y values by -1/2. So 9 times negative 1/2 is negative 4.5. 4 times negative 1/2 is negative 2. 1 times negative 1/2 is negative 0.5. And then those all repeat. So then I can cross out my y column because I don't need that anymore. So from my starting point HK, I'm going to go 3 to the left and down 4.5. Then 2 to the left and down 2. 1 to the left and down 0.5. 1 to the right and down 0.5. 2 to the right, down 2. And 3 to the right, down 4.5. Now, since I still have so much room on my graph, I could add several more points, but this is good enough for now. Then I can connect the points, and I have my parabola. You can see that it is flipped upside down from the way we graphed parabolas the other day, and that it has been moved to the right and up. Now, let's write the domain and range for these, or for this graph. The domain of quadratics is always negative infinity to infinity, or all real numbers. Even though we've shifted this graph and flipped it upside down, it will still continue on the left side to go all the way to negative infinity, and on the right side it will go all the way over to positive infinity. The range, however, is definitely different than the 0 to infinity range that we looked at the other day. The lowest that the graph goes is negative infinity. The highest that the graph goes is 5. In set notation, this would be y, such that y is less than or equal to 5. Then the last thing we need to write is the end behavior. As x approaches negative infinity, f of x approaches blank. And as x approaches positive infinity, f of x approaches blank. So if we look at both ends of this function, on the left side and the right side of the parabola, the arrows are pointing down. So both of these will be negative infinity. Make sure that you review the rules for finding a, h, and k from the equation, and for how a, h, and k affect the graph of the function. If you haven't memorized your parent function t-charts and graphs, this is going to be very challenging for you, so you need to get that done as soon as possible.